Hi, welcome to the Calculus 3, and this is, we call this the problem practice sections here. So we start a new unit, and this unit is vectors and the geometry of space. And in this video, we're going to go over the sum of the problems in the assignment number 1 worksheet. And this worksheet is about a three-dimensional coordinate system. And I just want to remind you, the assignment number and the lecture number, they are, they are associated with each other. So the assignment number 1 worksheet, basically, I have a lot of problems for you to practice after the lecture number 1 here, all right? So if you need a whole set of the full set of the practice worksheets, feel free to send me an email and I can mail to you. Okay, so in here we have a lot of problems on the assignment number 1 worksheets. I'm not going to go over every one of them. I'm going to pick and choose some of the one, maybe we did not cover in the lecture series, and then or is a little bit different in the actual series. I just want to let you know how to do it, so I'm going to do a few examples for that. Okay, so let's start here, all right? So remember, the assignment number and the lecture number, they are always related. So assignment number 1 worksheet is related to the lecture number 1, so that we'll talk about in the lecture series. Okay, so I'm going to leave this introduction slide. I'm not going to the worksheets here, all right? Okay, so the worksheets here. Okay, so this is the worksheets associated with lecture number 1 here. Like I mentioned, we have many problems in the worksheets because I firmly believe, right? So because I firmly believe the better way to learn math is practice, right? You practice, it will make you getting better in the maths here. Okay, so the first things here, I want to, we want to do is, let's take a look at a few problems here. So the first things I'm going to do is in problem number 4 here. Okay, so the problem number 4, and we're going to talk about is like, so in here they said, what are the projections of the points 2, 3, 5 to the x, y, y, z, and xz planes here. So I'm just going to do the XY planes here, right? So remember in the lecture series, we said this is our XY Z's, right? So 2, 3, 5 is something like here, and here, right? So this is the point 2, 3, 5. So when they say, the projection to the XY plane, that means this point here, right? So this point project to where? Project to the XY planes here. So when they project it, that means this one go down to the XY plane. So what happens here? That means what happened to your Z? So this point is going to go down to here, right? So this point is going to go down to here. So the projections of the x2, 3, 5 to the xy plane. So what will be the point here? Will just be the 2, 3, and what? 2, 3, and the zeros, right? Because z is equal to zeros here. Okay, so I think you guys can finish follow the same way. You guys can finish what will be the projection to the YZ and the XZ planes here. Okay, so for the next 2 problems here, the problem 7 and 8, and we did some this example in the lecture series, lecture number 1, so I'm not going to repeat. Okay, now I'm going to do another problems here. So this problems here is number 11. So we want to determine whether the points on a straight line or not. So how do I decide, right? So how do I decide the 3 points, in R3 is on the straight lines here, okay? So let me see if I have like this 3 points here, right? So how do I do that? And in the R2, you can say, hey, you know, like, do they have the same slope or not? But in R3 here, we did not introduce the slope concept yet. So I don't know how to find the slope with 3, x, y, and z. We know the slope is y2 minus y1 over x1 minus x2, right? So I don't know. So for here, the concept we use is we say, hey, if 3 points, right, is on a line in the space, right? That means if this 3 point is on the line in the space, that means if you add the two, the short side has to be equal to the longer side, right? So if you have a point it's not, so if this point is not on the one, so if you add this one and add this one, based on the triangle theory, that you add two sides always will be greater than you added another side, right? So this problem is just try to see, do you know the distance formula, right? So the first things I will say, okay, so the distance, right, between A and B is here, right? So let's see here, the distance between the A and the B. So what is the distance between A and B? So we know the distance is just like, we did the formula, right? So it's 3 minus 2 square plus 7 minus 4 square plus negative 2 minus 2 squares, right? So the distance between A and the B, and what is this one here? Is the square root of what? 26. So the distance, so we can do the distance of B and C here, right? So the distance of the B and C, let's take a look at what is the distance here. The distance here, B and C, is 1 minus 3 to the square plus 3 minus 7 to the square plus 3 minus negative 2 to the square, right? So what is this one's here? If you calculate that, it's 3 of the square roots of the 5 here. So the ACs here, let's take a look at the distance between ACs, right? So AC, what is ACs here? So it's 1 minus 2 to the square plus 3 minus 4 to the square plus 3 minus 2 to the square. So what is here? This is the square roots of what? Square roots of the 3's here. So we know the two short one has to be equal to the largest ones, right? So what is the largest one? This is the largest side, right? 3 of the square roots of the 5's, right? So this is the largest side. So let's try to see. So the square roots of the 26 plus the square roots of the 3. I know if you use calculate, you find out this is not equal to square roots of the 3 of the square roots of the 5. So that's why we say ABC is what? Not on the line, right? Not on the line. Right, because if they are on a line, so when you add the distance here, so if this is your large, the 2 points, right? So now, so 3 points here. So if this is 3 points here, right? So if you add so if here, the two short side has to be equal to the large side here. Okay, so that's it, right? So now you can finish the part B's here by follow the same ideas here. Okay, so now this one's here, the next one's here. Let's take a look. This is the easy ones here. So I want to find the distance, right? So the distance is the same here. So if you want to find the distance to the XY plane, right? So because we know whatever your graph here, right? So if you have a point here, right? So this is ABC point, right? So the distance to the XY plane, so what is basically here is this one's here. So what is this one's here? Last z's, right? Because they say the distance, so has to be the absolute values here. So the distance to the XY plane is what? is the 6, right? So that means I know this is the 6. How about to the YZ plane, right? So this is X, this is Y, this is Z. So YZ plane, so it means go to here. So what happens here? That means the X has to be, so the distance is what? It's the 4, right? So it's the X coordinate, so it's a 4. Okay, so now you can finish the remainings here. Okay, so this one's here. Okay, so now for the same points here, right? So for the same points here, how do I find the distance to the certain axis? So it's x-axis, y-axis, or the z-axis here, okay? I want to use the same examples here, right? So here, this is my x, y, this is my ABC points, right? I'm going to find the distance, right, to the z-axis because it's easier for me to graph, right? So the z-axis, that means this point go, so that means the distance from this point to where? To here, to the z-axis. So the same way is here, the distance is always the same, right? That means exactly the same, like for this one to the z-axis. So what is the distance here? So basically is what? In here, right? So in here, what is this point here? This one will be what? So this one will be like from this point, A, B, C, and to the what? To the Z's, right? So I know to here, the distance to the Z-axis here is basically, you try to project to what? 0, 0, 6 here, right? And so the distance will be what? Will be the 4 minus 0 to the square plus what? Negative 2 minus 0 to the square plus 6 minus 6 to the what? To the squares here. So the distance here, this will be the square roots of the 20, or it's 2 square roots of the 5. So if you can see here, so basically is you are looking for this diagonal, right? So the diagonal here, that will be the distance, because the distance ABC here is the same thing like this diagonal. So that's basically that's what is this formulas here, the diagonal here, right? So this is your diagonal here. So that's why, because the last ones here will become to zeros here. Okay, and that's it. And then the number 15, how to find the sphere, and how to find a sphere by complete square. We did a many of that. Okay, so I'm going to do one problem for the number 23 here. This one is also is pretty easy here. I'm going to find the equation of the sphere with the center. Okay, so if this sphere with the center, right, and this sphere touch the XY planes here. Okay, so imagine this, right? So you have some type of the sphere here, right? So kind of basketball here. It's kind of like you just sit this basketball on top of the XY planes here. I have a centers here. Now, what is the radius? Because it's bare, because it's touching the, because it's touching the what? Touching the XY plane. It's kind of, similar like a tangent, the XY plane, just touch it. So I know what is my radius. So what is my radius here? So the radius R will basically is what? If this is the center, right? They touch the XY plane. So what is the radius? Radius is what? Is my Z coordinate, correct? So in here, the Z coordinate is 6. So now I can write this sphere will be x minus 2 square plus y plus 3 square plus z minus 6 square and equal to what? R squared is 36. Okay, so this is very similar like we did for the previous ones here is distance, right? So basically this is similar like number 12, we want to find the distance to the XY plane. So this distance right now is the radius, right? So that's why the R equal to 6. So that's how do you get the spheres here. Okay, so now you can finish the remainings here. Then the 26 to 38, those are to identify what type of the regions we have. And I think we covered this as the example, the last example in the lecture number 1, right? Problem number 8, we covered that. Okay, so now the one I want to work on is number 46. Number 46, probably this one's here is the hardest one in this assignments here. So basically they said they have a two sphere, they, like kind of intersect, right? So they want to find the solid that is inside both spheres here. So it's kind of like, like if you have like a two spheres here, right? So you have two spheres here. It's very difficult to draw like in the, right? So this is a two sphere here. Then they intersect here. So then in here, you have a volumes here, right? So you have the volume. So they want to find the solid inside both spheres. So basically, if you look at one spheres here, right? So when they intersect here, right? So basically, like kind of you want to find the, the cap, right? The cap of there, right? So that's the volumes of that. Okay, so how do we do these problems here? Like I say, this one's here probably is the hardest one in the whole worksheets here. So that's why I like to work this problem, and so you guys can do it. Okay, so the first things here. So for this sphere, all right. So for the first one, and I will assume you know how to change it to a sphere formula by doing the completed square. So I'm not going to go to the detail how to do that. I expect you will know that. So this will be x plus 2 square plus y minus 1 square plus z plus 2 square equal to 4. So that means the radius, so this one, the radius equal to 2, and this one is already in the sphere form, so radius equal to 2 also, right? Okay, so now also in here, I want to know one thing here. When we talk about the distance between the two spheres, it's the distance between so it's equal to the distance between two centers. Okay, and so I know the distance between these two spheres here will be the distance between these two centers. And this one's the center is 0, 0, 0, right? This one, the center is -2, 1, -2, correct? Okay, so now I know the distance here will be -2 minus 0 to the square plus 1 minus 0 to the square plus -2 minus 0 to the square. So what I have here, I have a square root of the 9, so it's 3. So I know the distance. Okay, so in here, and this graph become kind of right? So this is the distance between, right? So this is the distance between these two spheres here, okay? So because of those two spheres, they both have the radius is 2, okay? So we know the both they have the radius is 2. So that's why I know the area has to be symmetric. Oh, the volume, the area, they kind of intersect. So the area, right, is symmetric. Okay, and now, so the areas here, because it's that means, there's one cap here and other cap here, right? So the total volume of the solid is what? The total volume solid inside both sphere inside both sphere consists, so basically it's what? Consists of, okay, the two caps of the sphere. Okay, so that means basically it's compared, it's the two caps of the spheres, right? So, okay, so the distance is 3, right? So the distance between the center to center is 3. So the caps and these caps of the sphere, the height of these caps is what? So the height is here is what? Will be the 2, because radius minus, right? So 3/2 here. Why is 3/2? Because this distance between the two centers is 3, and they are symmetric, so it's each take a half, right? So it's -3/2. So the half here, so the height is a half. So what I mean here, so if you look like this one, right? So this is a sphere, remember, right? So we said now here, this is the, so this is the top of the cap, right? So if I have a cap here, right? Right, so this is the top of the cap. So the height of that is 1/2 here, okay? So now I need to calculate the volumes here. And so the volume of this sphere, so the volumes here, I'm going to use different colors here. So the volumes here, yes, the formula here is pi. I'm calculating the cap of this volume. This is pi times h squared and r minus 1/3 h. Okay, and you will wonder, you will say, hey, where did you get this formula? Okay, so this formula here, yes, where did I get it? This is from your calculus 2. So when you learn in the calculus 2, when you try to find the volumes, right? So you need to go to review your calculus 2, and then you will see these formulas here. So this formula is try to find the volume of a sphere, the cap of the spheres here. So that's why you need to go back to review. If you don't remember it, go to find it. So after that, I'm not going to show you how to prove this one anymore because we did that in the calculus 2. Okay, so now you can get these ones here. So you can just plug the number. So this is the pi, and the height is 1/2, right? So this is 1/2 to the square. Now what is the radius here? Radius is 2 minus 1/3 and the times 1/2. Okay, so I know, so the answer is, so one of them is 11 pi over 24 here. Okay, so then the total volumes here will just be 2 times the 11 pi over 24. So the total volume for this answer here is 11 pi over 12 here. That means if you have a sphere, they kind of intersect, and then the region, the volume of the region, these two spheres share, that is this part. It's very difficult to, probably you can see that in the You know, can you see that in the 3D things here? So the way we use it, so this is the key formulas, right? We use here, right? So, and this formula here, this is what we learned in the algebra, in the calculus 2 here, when we try to find the volume for the different figures, right? So you might want to go back, try to review this. I think you can find this in kind of the, I think in the topic under calculus 2, when you is when we talk about the revolving x-axis, y-axis, how about it's not revolving, and find a certain volumes here. You can find this formula in there. That's why I said this one's here is a little bit harder. I think it's the hardest topic for this worksheets. And so another things you need to learn, you need to make yourself a note is, you know, when we talk about the distance, right? So the distance between two spheres is equal to the distance between the center of these two spheres, all right? That's it. So if you know here, then the number 47 is to find the distance between the sphere, you can know that. So you can do that. So I think that's it. So for this worksheet, this is the worksheet associated with the lecture number 1. I think combined with lecture number 1 and the several problems we did in here, I think you should have no problem to get all the problem done correctly, right? So all these ones here is just a good practice problem. And so remember, right, you always need to practice. So the practice make you good at math, right? So don't forget, finish the worksheets and practice, practice, practice. That's the key to be successful. All right, that's it. And then I'm looking forward to talk to you. We're going to start our lecture number 2 here. And in the next video, we're going to talk about the vectors here. Okay, so after lecture number 2, we're going to work on the worksheets on the vectors here. Okay, that's it. And I hope you enjoyed the video. And so it's nice to talk to you, and hope you have a good day, and make sure you finish all the problems in this worksheet so you can master the concept, right? Okay, that's it. Okay, bye. Talk to you later. Okay.